All right, so here is the information that we need. Let's go ahead and load up this. All right, so here's what's up. We need to do the assembly, like I said, which is all the parts together, which is a completely different file type. And as soon as this loads up, we'll be good. Okay, so it's a completely different file type called an assembly, where you put all your part files together. And we're going to do that. The problem is we need one more part file. And the part file we haven't done yet is the piece of train track, which is medium difficulty for this set of parts. And does this still work? Yeah, it does still work. Why is my thing always let's go like this. Sorry, folks. Mouse. Save. I just want. Do I need to exit this? Sorry, folks. I do think it is useful to have that application active. Suppose I could restart the recording, but you can always fast forward. And mouse. Show mouse clicks. Start scale. Why? All right, well, I guess I'll fix it later. Jeez. I just want the little clicks to show up. All right, well, anyway. Okay, so the piece of straight track looks like this. And there's actually one dimension here that contradicts itself. I guess they didn't go back and handle it, but that's fine. The way we're going to make this is by starting with just a full block, like a nice sort of brick. That's the maximum dimension in every direction. Then we need to make this, positive nub on this side and its reciprocal indent there. And then we just need to make these trough things. Okay, it's not that bad. Let's do, we need a new part file, of course. And once that pops up, we'll have something to do. Go ahead and log in when you get here. That's probably a good idea, especially if you get in late. And there we go. Okay. So, like I said, let's get some dimensions here. And the dimensions of our block are going to be the sort of cross section kind of area, which it's going to be a rectangle. The maximum dimensions. Well, we can think about which way is front here, but I guess it's not super critical. I guess if we're going to do, I do want this to come out flat, so I'm going to draw this small edge on the front plane and extrude it back. The extrusion is going to be 12-inch, and the size of the rectangle is 1 inch tall. So it's 1 inch tall by this largest dimension is 3.4. So we're going to make a 1 by 3.4 rectangle and extrude it 12. So let's go ahead and do that. Start a sketch. Front plane. Let's go. Let's do all these settings. And, okay, so we need a sketch and a rectangle. And from the origin, just because, actually, um, no, we could have done this a different way, but that's fine. Okay, so I'm gonna make this one, or you could see before I even click, I have those blue or those number boxes up. I can set the dimensions without even getting the dimension tool. The width is 3.4 and tab over, and the height is 1, but you can do it the traditional way with just making a rectangle. And that's 3.4 by 1. We're going to finish sketch and extrude. There's only one thing to extrude. We don't need to choose it. And our extrusion distance is 12-inch. Okay. So there's our block. I think it's easier to do the nubs before the troughs because the nubs need a center snap. So let's go ahead and do this positive end. And so the better view of this is actually on this side. And so we have sort of a throat area that's 0.6 wide. And the center point here is 1.7 from the side, which means it's the center, because if you call the whole thing is 3.4. So 1.7 from the side. We're going to make a circle here that is centered this way and 1 inch from the edge of what we have. So that's the location, and the size of the circle is radius 0.7, and they give us the radius because the finished product is an arc. But since we're going to make a circle to draw our shape, we need to double that. So once again, it's centered left to right. The center point here is 1 inch off of what we have, and the circle is going to be 0.7 times 2. I think I can remember those 3 dimensions. We're going to start a sketch on the top face. And for me, it doesn't really matter for this one, but when in doubt, make it so you can read the word. And then that way we know the positive end is down here. So let's just go ahead and make a circle because it's always going to be a closed loop. We can just put it out here in space. And the size of the circle is 0.7 times 2, otherwise known as 1.4. And we need to locate it. The distance from the center point of the circle to our block is 1. And the distance from the center point of the circle to the edge of everything is 1.7. And then we just need to build sort of the, I don't know what you'd call it, I guess the throat area. And it is 0.6 wide. And I'm not sure if it explicitly says anywhere, but you can definitely, oh yeah, it does. I was wondering if it explicitly said it was the center on the center line of the whole thing. Of course it is, but the place that it shows is that, okay, so this is 0.6 here, and the other edge is 0.3 off of it, so it's clearly measuring from the same center point, even though we could just infer that it has to be centered, otherwise the part wouldn't work. Okay, so we need a rectangle like here-ish, but because I want it centered, I'm actually going to draw 2 rectangles from the center. First one here from the center of the circle that goes back to the block, and the other one from the center of the circle that goes back to the block this way. And I need to make these both 0.3. So the distance from our center line to the side is 0.3. And the distance from the center line to the side is also 0.3 to give us a 0.6. Okay, there's another feature here that you might not be familiar with. So it says radius 0.19. What that's pointing to is there's actually a very tiny fillet here and here to sort of round it over. And there is, just like chamfer, there's a fillet tool that is a sketch feature. Where are we? There we go. What's up? How long is what? 0.3 from the center of each of them, and the direction this way is just the center. What's up? The full block is 1 by 3.4. And I'll just show you here. Edit. No. It's 1 by 3.4 this way, and then we extruded it 12 backwards. Okay, so just like with chamfer, there is a sketch version, and you know it's a sketch version because we're in sketch mode. And I think the fillet goes, okay, first of all, if you can't tell from my tone, don't do this. But the rounded over edge, you can, oh, it's not going to even let you do that in sketch mode. But either way, for fillet and for chamfer, we are going to prefer to do it in part mode once we have some material to actually fillet. Okay, so our sketch is complete. We're going to finish sketch. We're going to extrude, and we're going to choose all the stuff we made, which are the circle and the 2 rectangles. Okay, and we don't want it to go up. We want it to go downward. And we only want it to go to the other side. Oh, wait, I didn't even choose all of it. We only want it to go to this end, which we know is 1 inch, and that's fine. You can also choose 2, and we want it to extrude until it gets to the bottom. That's another way to do it. Either way, it needs to be the same height. 2 is useful when you don't have a direct measurement of things, but we know that's 1 inch. Okay, and then those filleted parts are this edge right here and this edge, these 2 edges that are sort of inside there. And you saw I chose the edge and it actually gave me a context menu for fillet, but that's fine. We'll choose fillet up here. And the dimension, which we want to type in before so it doesn't get weird, was 0.19. And the edges we want are this one. And you can see the shape it makes. It sort of rounds it over. And you can actually select this one through the part. It's the one on the other side. And you can do this on the same part feature, meaning choose both of them because of they're the same dimension. And that is one of the sides. The other side, or the other receiving side, is very similar. It's going to be a similar shape, except it's going to be drawn on top of the part so that we can cut extrude. And similar dimensions. We've got the same rounded over fillet, which we'll do last. This circle, or really this arc, which because they give us the radius, we know it's an arc. We're still going to draw a circle, but it's 0.75 times 2, which makes sense. If you're making something out of making a toy, you wouldn't want anything to be the exact same size. It wouldn't fit together with a tolerance. So we're going to make a circle that is 0.75 times 2. It's going to be also 1 inch from the edge. That distance is going to be 1 inch. And 1.7 from the side means centered. And then the throat part is 0.65 all the way across, also centered. So we're going to do the same rectangle thing, except it's going to be half of 0.65 in both directions. So 0.75 times 2, 1 inch off the back, centered this way. And I'll come back for the other numbers here in a second. Okay, so start a sketch on the top. And I'm going to go up here. You can see where I'm sketching what we already have. And so I need a circle. I need this dimension is 0.75 times 2, otherwise known as 1.5. And I still have the dimension tool. I'm going to dimension the distance from the center of the circle to the edge of the block, which needs to be 1, just like the other. And the center point to the side of everything needs to be 1.7, which you might get a soft snap there anyway. Save you a second. And so then we just need the throat part, which is a rectangle from the center going this way, snapping to the edge. And the same thing this way, snapping to the edge. with the dimensions that we're interested in. The distance from there to the center needs to be 0.65/2 or 3.25. Same thing this way. The other one was 0.6 total width. This is 0.65 total width. And since we want half in either direction to center it, there you go. And now we can cut this out. Finish sketch. I think that's it. Finish sketch, extrude. What's up? Excuse me, 0.325 in either direction. Okay, so we're gonna choose everything we made, and it will let you choose things or whatever. It'll make you choose all the different parts. And once we choose everything we just drew, we don't want it to draw up. And also we don't want to create material. If we switch to cut, it will switch the direction. Make sure that when you're doing any part feature, like extrusions or cut extrusions, whatever, you're looking at it from a 3D angle. It doesn't have to be the house, but it can be a corner or anything like that, so that you know that when you're cutting through material. Because if you do cut into space, so I have it set to cut, but I'm cutting up, it's going to give me an error and say that you messed up. Okay, so always looking at it from a corner, and there we go. There's our cutaway. We just need to do the same thing as the other side, where we fill it off these little edges right here, like that edge and that edge, which are, and you can see here, it says radius 0.19 times 4, and that's because there's 4 of them. There's 2 on the positive side and 2 on the receiving side, and they're all 0.19. So we could have done them all in the same part feature, but we're good for now. We need a fillet, and we need to fillet this edge and this edge, and it still should be set to 0.19. And there you go. Okay, and the only other part feature is the troughs, or the train tracks. And let's look at them. So the only dimension on this one that's relevant, the other ones are all over here. I'll go there in a second. The only dimension here is that the bottom of the trough is 0.75 off the ground, and the top of the block is 1. So that means the cutout is, the difference is 0.25 deep, except over here, and I'm almost positive these are contradicting the same dimension. Over here, it says it's 0.175 deep. So it doesn't really matter so long as you're doing both sides the same. I'm going to stick with this one because I don't think maybe we'll just do 0.25 to keep it even though 0.25, well, are decimals odd? I don't know. Okay, so the troughs are all, these dimensions are all measured from this side. So we're going to make a couple rectangles that are this shape on the top. We're going to make these long, narrow rectangles that go the entire distance. And then we just need to dimension the distance from the side to this part of the rectangle, and the distance from the side to the far side of the rectangle, well, the far side of this one. And those dimensions, the distance from the side to the start of the trough is 0.4, and the distance from the side to the other side of the trough is 0.75. And you could do them all like this as a stack dimension, where the other rectangle on this side, we could dimension the 2 lines from there over there, but we also know that it's centered, so we could do 0.4 from the other side and 0.75. The key numbers here are 0.4, 0.75, and we'll do a 1/4 inch deep. Okay, so we're sketching on the top, and we just look at it from the house. Put a sketch on the top. And because both of these troughs are the same size, or the same cut extrusion, I'm going to do them on the same sketch and then do them in the same part feature. Okay, so our first rectangle is going to go from one side, soft snap on this edge. Make sure you don't get the center point. It will prevent it from being correct. So we have first click. This is with a regular rectangle. First click, soft snap somewhere on this side of everything. And second click somewhere on this side. That's a soft snap of the edge, not the green dot. And it doesn't have to be super accurate. It just has to be close. And our dimensions are the distance from the side to this first part of the rectangle, and that was 0.4. And the side to the other part of the rectangle is 0.75. And there is the shape of our cutout. We just need to cut it down 0.25. Is this not on the edge? Oh, my first click didn't click on the edge. That would have been an issue. And yeah, and this side, what dimension do I still need? Does this not, I'm gonna do it again. Because I can't be confident that that snap will work. Let's try again. Okay, rectangle. First click on the side of everything. Why is it not choosing that? That's really weird. Is it? No, okay, it's good. That was a weird where it was snapping. Okay, distance from there to there. Again, 0.4. Distance from the side to the other part of the rectangle, 0.75. And I just need to do the same thing on the other side, and so that we can do a single cut. First part, let's look at it straight on. Always looking at it straight on when you are in sketch mode. Okay, first click somewhere on this side of everything. Second click somewhere on this side of everything, but not the green dot. And like I said before, the dimensions they give us in the working drawings are stack dimensions, which is the way we're going to do dimensioning because I think it looks really good and it's a clean way of getting a lot of information in this space. But they're all dimensioned to the same side, and we could put those dimensions in. In fact, let's just stick with it. When in doubt, dimension things the way they look on the drawing. So this side of the trough is 2.65 from the same place, and this side is 3 from the, so 2.65 and 3 are the numbers we're looking for. So we've got the dimension tool, distance from our first side again to here was 2 point, well, it's a close guess. And from here to here is 3. And there we go. Should say fully constrained down in the corner, the bottom corner. And there we go. There's our sketch. Finish sketch. Extrude, looking at it from a side, and choose just the rectangle that you made, just the other rectangle, and switch it to cut. And we don't want to cut 1 inch. We want to cut 0.25. Okay, and I'll give you a second to catch up, and we'll start the assembly here momentarily. I want to do it on the same recording if possible. Yeah, yeah, there's a pass. Uh, show, I got the dot back. Okay, I think I got it. Okay, even though the background's blue. Okay, so we need to do an assembly, which is, like I said, a completely different file type. And we are going to put everything together. It's obviously going to be a lot of new stuff, but it will follow along. First thing you need to do, well, first of all, let's go ahead and start a new assembly from the same shortcut. And I need to find where all my part files are. Okay, the first thing you need to make sure is one of the settings I told you at the beginning is for assemblies. And if you haven't done it, or you're sitting at a different computer or something like that, where your settings got changed, you need to put it back on. And under Tools, Application Options, and if you've been sitting at the same computer and nothing has changed, you did this the first day. But under Assembly, the Assembly tab, you need to turn on Place and Ground First Component at Origin. Okay, and hit Apply or OK, same thing. And so under the Assemble tab, which is the main one, we're going to place, and the default is just regular place, which is what we want. And for an assembly, I think I clicked it. Did I click it? There we go. For an assembly, the first part you bring in is going to be whatever you attach things to. In this case, it would be the train body is what we're going to start with as our main thing. If you have some sort of base or platform or structure or that sort of thing, that would be what you place first. And I need to find where in my thing I hide all of my any train parts. Okay, and train body. There we go. Okay, so we're going to do train body first. And apparently I have mine a red color, I think, which I do actually want you to put some creativity into this. When you change colors, make sure you do it in the part file, and make sure you do the one that's called default. And it will let you choose any of the colors or materials if it ever, there we go. Feel free to do that and save it in the part file. And then in the assembly, oh wait, I already made that one. It will pop in with whatever color. Hopefully, I'm not going to switch everything back to the default color to make it easier. Hopefully you can handle learning with different colors. Okay, so the first thing that came in is, all right, well, over here in the browser bar, which is critical, the browser bar in a part file keeps track of all of your part features. And then inside of them are all the sketches that were required to make them. In an assembly, the browser bar will have all of the parts that you bring in, and you can affect like constraints and stuff like that. Okay, so within the train body, I'm not sure what that dot means. What does that dot mean? Well, whatever. Okay, you see over here that the blue block has a push pin in it, like a thumbtack, and that means it's grounded. In this universe, this can't move at this point. You can turn it off, but it's centered, and just like with a part file, this universe has its own origin planes, which you can use, and we will. But then within the train itself, it has its origin planes, which will actually probably, yeah, they line up exactly with this universe because, when I say this universe, this assembly realm, void, they all have their different properties. Okay, so this is our base, and we're going to attach everything to it. The first thing we're going to attach is the hitch peg and magnet. And you can see that the hitch peg goes directly through the hitch magnet, and they are flush mounted on the back, and well, they're attached, they're constrained to the back. Is there a back view of everything so you can see how it's not indented? No, there's not actually a view of an assembly with everything in the back. You just have to take my word for it that these line up. Okay, so the way we're going to do this is first by placing them. Let's go ahead and place, regular place, which I don't think I've ever used the other types of place. And let's place hitch magnet and hit open and click once to set it. And we only want one. So once you have one set, right click OK. And that's how we're going to get 4 wheels in and 4 axle pegs and what have you. When you go to place, you just bring in a few of them. But we only want one. And you also notice that this is not constrained. We only had auto constraint on for our first piece. And over here, we have our hitch magnet, which has its origin planes. And those are different now because they're in a different place. And what we need to do is attach it to the back here. In fact, I'm going to go ahead and bring in the hitch peg also because those go together. Hitch alphabet, hitch magnet, hitch peg. And we'll place one over here, right click, OK. So what we're going to do is called constrain. And inside of constrain, there are several different types. The first one that is going to be done more than all the other ones combined is called mate. And within mate, there are 2 types. Mate and flush. It's sort of weird that mate is a type of mate, but we'll just have to go with it. It's sort of like this is a mate constraint unless you want them to flush. And you can see with this little pictograph, mate, this mate attaches things like your gluing faces together, and flush lines them up so they're even facing the same direction. And there are other types: angle constraints, tangent constraints, insert constraints, symmetry constraints. I don't know. You would think that like this peg would be best with the insert constraint, but what we're actually going to use is mate constraints, and we're going to mate the axis. Hold on, does it not let us? Oh yeah, you can't flush. Mate the axis of these whatever cylindrical part to the axis of the hole, and then that way they'll always be lined up, and it's easier to adjust than the insert constraint. Okay, so from scratch, let's constrain, leave it on mate, leave it on mate. And the first constraint we're going to do is actually attach the face of the, well, really, it's the, and it, when you're doing like a mate constraint, the order that you click on things doesn't matter. But the faces we're going to attach are this flat part, and especially with round parts like this hitch peg, there are a lot of different things to click on. There is this face, which is the flat surface there. There is the center axis, which is just this imaginary line that goes right through the entire cylinder. There is the center point. If you put your cursor over the edge, you'll get a green dot. We are never going to use the green dot one. It's going to be flat faces to flat faces and axes to other axes. Okay, so again, from scratch, we've got just our train, and we're working with the hitch peg now. Excuse me, hitch magnet. Constrain, leave it on mate, leave it on mate, and we're going to mate this face. Make sure you get the arrow pointing straight out. If you get the green dot, it's wrong. Okay, so we're going to mate that face to this face, something flat, well, the flat black part. And if you have things turned on, it makes a very satisfying sound, at least as far as I'm concerned. And I'll make you listen to it now. So it goes, all right, well, we've got that. And So if you look at it now, you can grab this hitch magnet and it moves, but it only moves on that one in the other directions. It is attached no matter where I drag it. It's never going to come off of the train body. I mean, it'll go this way because the plane goes on forever, but it will always be attached. Now we just need to make sure that it's centered. The center of the hitch magnet is lined up with the center of this. We're going to constrain and make sure your click on the magnet gives you the center axis lines. That one's broken. You see how it says it's broken? You can grab this one. There's a couple over here. So we'll choose the center axis here, and we want to do the same thing here. We want the center axis that's going all the way through, not the green dot. And there we go. There's the sound. And we don't want any offset. We just want to hit OK. Now, when you grab this, you should be able to grab the hitch magnet and have it not move at all. It will actually spin, which you can't really see with this. Oh, you can kind of see it with this texture. But because we haven't constrained like the spin, but we have constrained it's onto the axis and we've locked it onto the train body. The other one here, we need to do the same thing. We are going to constrain this face right here, sort of the flat part of the hitch magnet. Again, make sure you're not getting the green dot. And that's going to be what part of this is going to end up sort of essentially glued to that. And it's this underface right here. The underneath the head of the peg, there's this flat surface. We don't want the edge. We don't want the edge of this. We just want this flat surface. And hit OK. And now it's going to, just like before, it's lined up and it won't come off the train body, but it still moves in the other directions. So we need to do the same thing as before, where we constrain somewhere the center axis, which we can get somewhere on the cylinder part of the peg, to the center axis here, which you can choose the outside of the magnet or the inside, anything that's longitudinal and cylindrical, and hit OK. And again, you should be able to grab a part and not have it move at all. And we'll be good. Okay, so there's one or two things. Let's do a couple other, well, let's do the rest of them. Okay, so let's do smokestack next. Just it's a simple one part that goes on the top. Element OP smokestack. And you can see how they come in sort of pointed roughly the correct direction because we kept the concept of forward or the front consistent through all of them. They're all going to be pointed the correct direction, but you can, you can orbit things around inside of the assembly, but you don't really need to, because when you go to, even if this came in sideways like this, if it was made sideways, it would, the program, I almost said the game, the program would guess that's how you want it. But it doesn't really matter because constraining things, just like constraining dimensions in a sketch, puts it in the right place, but also locks it in the right place, moves it to the right place. So we're going to constrain and mate this face right here. Make sure you're getting that arrow that points out. And the face we're going to mate that to is down in the bottom of the hole we made for it. And it will, we hit OK. It will be locked in there, except not locked in the hole. It's locked in, it's locked at that height, like that. And then we just need to do our center axis thing with constrain. And we need something on the out, something that will give us that center axis of the smokestack, which is most of it. You can click on. And the other click needs to be somewhere on the inside wall of the hole for it. And we hit OK, and there we go. And again, we grab the part and it doesn't move. Okay, and let's do the cow catcher next, because that is just a nice single part to be done with. We will place cow catcher, hit open. And this one's a little tricky because it requires 3 different constraints, not 3 for the peg, but one will be for the face. Well, let's just go through it like we know how. Okay, what do we know? Well, we know that this face, right, this face, this flat part where the pegs are sticking out, will end up being as if it was glued to the front. So we can go ahead and do that constraint. Constrain, okay, our 2 selections. The first one is this one, and you can see it automatically switches to the second one. If you wanted to go back and change things, you could, or just hit undo. And so that's our first face we're going to constrain. The other one is somewhere on the front here, which I think if I point it this way, it's actually brighter. Nope, it's not. So that was our first click there. Our second click is somewhere on this surface. And hit OK. And now it is, it still moves because it's not constrained, but it's locked to the front of the train, which is what we want. And the next step is we need to constrain one of the holes. Well, actually, we need to do 2. And the one we're going to do first is this top center one. Because it's upside down, I don't want to constrain the wrong peg to the wrong lower one. I know that the top center one belongs to this top center one, so we'll go ahead and do that. Let's go ahead and constrain. And first constraint is going to be something that gives us the center axis of this one. And the second click is going to be something that gives us the center axis of the hole it's supposed to go in, which will be somewhere inside the cylinder. And hit OK. Now we grab it and it still moves. We have our 2 constraints, but it spins. And actually these spin also, but you can't really tell because they're symmetrical all the way around. We need to do another constraint in order for this to work. There are a couple options. We could just do another like axis constraint. That's fine. And if you made all your dimensions correctly, it will work. If you do those 2 things and it doesn't pop, it means you have a dimension wrong somewhere. There are other things like we could flush, constrain, switch it to flush, and we want the bottom of everything to be flush with this small bottom edge of the cow catcher. That one works also. However you do it, either that first way I showed or this way, when you're done, you should be able to grab it and it doesn't move. All right. And let's see here. Let's do the wheels, since that's the only thing left. Okay. Well, we need 4 wheels, 4 axle pegs, 2 linkage arms, 4 linkage pegs. Let's just do the wheels first, and then we'll bring in the other parts. For wheels, we'll choose it, hit open, and we might as well get 4 of them. So click 1, click 2, click 3, click 4, right click, OK. And we're going to follow the same path as the other, which is constrain a flat surface here to something that's the back flat part, nothing that's a green dot or an axis at this point, just the flat part. And if I did it correctly, yeah, there you go, hit OK. So this one is now attached to the side of the body. I just need to get it lined up this way, lined up with the axis. So I'll do the same thing here. Anywhere on the wheel, yeah, anywhere on the wheel that gives you the center axis, mated with anywhere on here, which is just going to be the inside of the hole there. We'll do that, and I'm going to fly through the rest of these. We want to mate this face, not the green dot, to there. Okay. You can hit apply and do another one, but I'm just going to hit OK because I actually need to move it out of the way in order to see the thing I'm going to constrain it to. And I want to do this axis here and this axis. Hit OK. And we'll do the other side. Constrain. flat surface to flat surface. Apply, and I can do this while it's out of the way. We'll do this one to there. Hit OK, and one more, this one, somewhere on the flat surface. Hit OK, and we got to get it out of the way. And constrain center axis to center axis, and hit OK. All right, so we've got some wheels on there, and they spin, but they don't move other than spinning, which is what we want. We need axle pegs to go in the middle. We need linkage arms to connect the nubs on the wheels. And then we need linkage pegs in the holes of the nubs for the linkage arm. So let's go ahead and let's do axle peg first. Do I have axle peg? I do have axle peg. Hit open, and we need 4 of them, just like before. 1, 2, 3, 4. Right click, OK. And we're going to do the same thing. It's a little finickier here because the only flat surface we have is the distance from here to here. This first ring is the only flat part that's the right height, or the right face to constrain to. Technically, this outside is too, but we're going to ignore that. So we're going to constrain, and the part we want to constrain, or the face we want to constrain, is this under part of the peg. And that flat surface, not the green dot, needs to mate with this flat surface. You can tell you have the right spot because you have that red arrow pointing out, not a green dot and not an axis. This is a face constraint. So we want to constrain those two together, and then we can hit OK and do another one. We want somewhere on the wheel that gives us the center axis, and somewhere on the axle peg that gives us center axis, which this rounded part of the head does, this flat part, something that's not the green dot, and hit OK, and it should be locked in there. Everything should be locked in. It can still spin, but that's fine. And let's do the rest of them. We're going to mate this face. It pops over, apply, and then this axis to something there. It mates those. Same thing on the other side. Constrain this flat part there to this flat part there. Apply, and then something that's an axis to this axis. Hit OK. And constrain last axle peg. This one goes to there. Apply, and axis to axis. All right. And so now we just need linkage arm. And here is the test. This is the first time you're going to find out if you have the correct dimensions, because the linkage arm won't work, or it won't connect, if the distance between the wheels is incorrect or the location of the nub is incorrect. Either of those will make it not the correct distance, and it means the linkage arm will jam up a little bit. But either way, we're going to place it the same way. We chose it, hit open, and we just need 2 of these, 1 for each side. And it's going to work the same way as the pegs. We're going to mate this flat surface right here because that's where it's supposed to line up. And then we're going to do an axis constraint, an axis mate with the axis of that. So let's go, and then we got to do it to the other wheel. You'll see here, and it'll make sense, hopefully. So we're going to mate this face, the flat part of that one, to the part that you would glue it to, which is this face here, not a green dot. Remember, never a green dot. Hit OK. Let's move it out of the way a little bit, and we just need to do an axis constraint, which the center axis of this hole is you can get from the inside of the cut or from the outside edge. Either way, they have the same center axis. And the same thing here. We want to mate it to this center axis, which you can get a bunch of places. Hit OK. And at this point, it should move like this, move a bunch of different ways, which we obviously don't want it to do. It's weird how it's guessing. Why is it not letting me move this down? Can I lock it in somehow? Let's look at it straight on. I don't know why it's doing either way. We'll find out shortly whether or not I did it right. And since we are the first one we did was locking this face to the wheel, it still lines up with the other one. We just need to do one more axis constraint from wheel to this side of the arm, which I don't know why everything's weird for me right now. Either way, we just need the axis constraint, which is the axis of this to the axis of this, and hit OK. And something is wrong because there we go. Okay, it should, if you grab one of the wheels, it should move around. Actually, really, if you grab the linkage arm and move it, it should go all the way around. If it like jams or like sticks and then like pops through, there's something we need to fix, which is actually easy to fix. You can go back and open up one of the part files, change something, and it will update through. Like if I did, I'm not going to do it. I do want to change the color though. I don't really care for that color now that I think about it. That's not what I want. Sorry for all these distractions. Nope, that's worse. There we go. All right, so then I save it on this side in this part file, and when I come back here, it has updated. And you can do that for any of the part features, like if the holes aren't in the right place, that's how you would fix it. Okay, and so this side is done. I just need to do the other side. Same steps. We're going to mate this somewhere on this flat part. Needs to be glued to this small. You can see where I'm clicking. It's just this. It's the part that would be locked to, which is that one. Hit OK. Let's move it out of the way so it can constrain, or we can get to it. And we want to lock in the center axis on this side to the center axis of something there. Hit OK. And it's weird that it lined up exactly already on the other side. But here we are. And let's do the same thing that we did here, which is one more axis constraint of that to the axis constraint of that nub. Hit OK. And there you go. That works. We just need a couple of linkage pegs, which are these. Hit open, and actually not a couple. We need a couple. We need 4 of them. Right click OK. And same process as the other pegs. Constrain, leave it on mate. I want this flat underside to be locked to really anything here is the correct plane as long as it's not the green dot. And hit, did it come through? It did, it's just clear. Hit OK. And then I need it to, which it looks like it's broken, but it's not. It's this little peg goes right in there. We need to constrain, get the center axis of something with the center axis of this, and hit OK. All right, and where'd my other little pigs go? Oh, they're way up there. That's something that can happen. In an assembly, you can grab a part and think that you're moving it closer, but it guesses you want to move in the other direction because you're looking at a 3D environment from 2 dimensions, and it can guess wrong sometimes if you're moving it. So be aware if something disappears, That's something that could happen. Okay, so let's do the same thing over and over again. We'll do this one. Constrains to somewhere on this flat surface. Hit OK. Let's move it out of the way so we can still see it. Constrain axis to axis. Making sure not to click the green dot. And just these other two. Made that to that. Hit OK. We'll go like this and constrain not the green dot, the axis. Something else that gives us the axis. Hit OK. And is it one more? It is one more. Constrain. And constrain. And OK. And the very last step is constraining this center axis to that center axis. Hit OK. All right. We aren't going to put the train track in the assembly because the next thing we need to do involves more of the train track. And we're already kind of long on this recording. So go ahead and save it there. Make sure your file, save. And you probably want to call it, just to keep everything in alphabetical order, train assembly is probably a good name for this, or mini train assembly, whatever you are calling things, like train assembly. Okay, you don't have to name it assembly. It knows what file type to save it as. .iam is assembly or inventor assembly, but train assembly is still a good name for it. And that's where we're going to end it for today. Okay, so the assembly is going to be an assignment. Obviously, it's not due today, but it will be one of the things. And it's not really something that you can skip because you need it for the next part. We're going to do some animations with it as is. Or, yeah. So let's call this, do I have something called train assembly 24? Okay, and that's it. Give me a second and I'll post this up on the